Okay, well, thanks for coming, everybody. So it's my pleasure to introduce Professor Rob Johnston from Clarke University in the US. So Rob is mainly famous internationally for his work on benefits transfer, but he's also done some great stuff on valuing water quality improvements. The reason I'm talking into this is because there's all these people listening through GoTo seminar thing. So they can't see me, I don't think. Can't see that I haven't done my shirt up, and but they can hear me. So Rob's going to talk for maybe 45 minutes, and he's pitching this assuming that people don't have a lot of background in environmental economics. Now, I know a few people here do, of course, but I'm sure you'll still get a lot from it. So Rob, the floor is yours, and are you happy for people to interrupt?
Whatever's normal. I'm happy if people want to interrupt or wait to the end. I think maybe for the online questions we can wait to the end. But if folks in the room want to interrupt, that's fine.
Okay.
Okay. So So thanks for having me, Nick. It's been a pleasure having me here. Again, I'm going to start the talk with a little bit of background because I know that, or at least I suspect that we've got a mixed audience. Some of whom know a whole lot about environmental economics and how we think about the value of ecosystem services, and others who may have a little bit less experience. So we're going to start relatively basic and move up. As you can see, there's a whole relatively long list of people on the screen, at least a long list for an economics presentation. I know it's somewhat more common in natural sciences. And I just want to highlight this because basically this is a group of economists, ecologists, experts in communication and outreach. We've got someone from NOAA, the National Oceanic and Atmospheric Administration. So basically this is a whole long group of people with different areas of expertise. And the reason I highlight that is that one of the things about this project that is kind of interesting and unique is the extent to which all these things were integrated from the very beginning. But I'll talk about that a little bit later. So just at the beginning, a little bit of background, and again, this is a review for probably most of you. So when we think about ecosystem services, at least for as an economist, we tend to think about these as the outputs of natural systems that benefit society. Those can be flows, those can be stocks, but it's basically something that natural systems do that benefit people, right? So if it doesn't benefit people, it's not an ecosystem services. It's not an ecosystem service. And one of the other things that we think about as economists is direct versus indirect impacts. For economists to directly quantify a value, we tend to think about things in terms of the things that affect people immediately, right? So for example, if I'm a recreational angler, perhaps I value catching more fish, right? So that's the thing that I value. Now, there may be a whole host of other ecological processes and functions that contribute to that fish that I catch, or to that fish abundance, but generally, to the extent that the fish is the thing I value, the value of all those supporting processes, or regulatory process, or whatever, are realized through that fish, right? And so that's important because that determines what kind of things that we can value, right? So if the only thing that I value is the fish, right? Once I valued the fish, then I wouldn't also value the water quality and the other things that contribute to the fish, right? On the other hand, I may also value water quality in and of itself, right? So this is, the title of the talk was about disentangling ecosystem services, and the reason why I mention that is because this is one of the areas that we often get into trouble, is trying to figure out from these very complicated ecological webs, what are the specific things that people value or that people benefit from, and how do we pull those apart? How do we disentangle the value of the fish from the value of the water, from the value of the riparian vegetation that contributes to the water quality? And then how can you come up with values so that you come up with values that count enough of the main effects but don't double count them? And that's one of the main things I'm going to be talking about. So when we're doing ecosystem services valuation, what we're really looking for, again from an economic perspective, is a way to link the condition of ecosystems, whatever ecosystem we're looking at, to the condition of people or human well-being. I mean, that's really what we're after. Now, we may quantify that in dollar terms, but to an economist, really, all we're doing is trying to come up with a way to measure human welfare. It's not that we're obsessed with money. And in fact, you can have a lot of values that have nothing to do with money changing hands. And so, so that's one thing to think about, and that's another, and I mention that because it's something that a lot of people have misperceptions about in terms of economics. Now, environmental economists, for decades, we've been coming up with ways to measuring different market and non-market values associated with natural systems. So again, from an economic perspective, the ecosystem service concept is most appropriately, I think, viewed as kind of an evolution of that work. I mean, you can go back into the 1940s and different people were coming up with ways, recognizing that natural ecosystems had value and had been developing ways to measure those values in economic terms, right? So to an economist, the primary difference between an ecosystem services concept and things that we've been doing for 40 or 50 years is that ecosystem services approaches have more of a fundamental grounding in the biophysical sciences, in ecology. It's a stronger link to ecology rather, so we focus on the ecological processes that generate those services rather than just saying, here's the final service or thing that people value. Okay? So lots and lots of interest recently on how we estimate ecosystem service values. Challenge is that people are so eager to do this that we often kind of rush in, and you'll have either groups of economists doing ecosystem service valuation where we don't speak to our biophysical colleagues, or we have ecologists and biophysical colleagues doing valuation and they don't speak to economists or other social sciences. And as a result, we tend to have lots of published results in different journals that are excellent on one side of the spectrum, but really kind of lousy on the other side, right? So you'll have great economics that's kind of built on sometimes what I can call cartoon ecology, or you'll have fantastic ecology that's built on kind of cartoon economics. And what this seminar is about the challenges and process of trying to do both with equal weighting. So you get, ideally, good economics and good ecology. And what that means is you kind of have to start the process from the beginning, and that's a little bit different from the way this sometimes happens. So this is just kind of a simple little framework that I put together a couple of years ago. And again, this is just my version of it. You can see other versions of this in other publications. There's nothing particularly unique about this. But this is just a way to kind of to conceptualize how an economist thinks about ecosystem services, right? So we start with ecosystem properties. This is purely biophysical stuff or biogeophysical stuff. And basically here we're thinking about ecosystem structure, composition, and function, right? And so at this point, this is just stuff going out into the natural world, and I'm drawing that little artificial distinction between humans and ecosystems, realizing, of course, that humans are animals like everyone else, but still. So we think about ecosystem properties. Now, at this point, they haven't really affected people yet, right? And so we think of that leading into what we call, at least in economics, outputs or final services. These are the things that affect people directly, right? So you can think of this box, the first box, ecosystem structure, composition, and function, being something like, for example, the process that might go on in a wetland or in riparian vegetation, something like that, right? The ecosystem is just going about its business, right? That leads to a set of what we might call final services. These are the things that benefit people, right? So, for example, riparian land might filter out water so the water is cleaner, right? And people benefit that because perhaps they drink it or they swim in it or they fish in it or something like that. It might also increase fish abundance, and that might be valued for a variety of purposes. So when you see final, this is what these are things that value people directly. There doesn't need to be any further biophysical change before it affects people. So an intermediate service, when we talk about that, nature still has to do something before it benefits people, right? So if the thing I value is fish, and I don't particularly care about water quality other than that I'm a fisherman and I care about fish, well then we could view water quality as an intermediate service, and that before it can affect my welfare, it has to enhance fish abundance, which are what I care about. On the other hand, some people might value water quality directly. Say if I swim in it, if I drink it, in which case that is the final service. So depending on who you are, you can have final services can be different to different people, right? And so you can think about kind of a, almost like a flow chart of or like a web of ecological changes ultimately that lead to effects on different groups of people. And what we're after is trying to figure out where it is that those ecosystem changes finally touch on people and finally benefit people, right? So you think about reducing nutrients in a water body. Well, that doesn't affect people directly. It's not that anybody benefits from the chemical process of having less nitrogen in a water body, right? But that might affect, algae and oxygenation and ultimately affect things that I might care about, say fish, or water clarity if I care about aesthetics. Now that's something that affects me directly, and that's that kind of node, and that's what we're after. Now, in some cases, those final services can affect me immediately. Utility is just economists' fancy way of saying well-being. So certain final services like say clean air that I breathe or water that I swim in, that affects me immediately. I don't have to produce anything. But other things affect us. For example, certain kinds of fish, well, they're valued by people who might harvest them for commercial purposes. And so there's some human production process that goes on to change those final services, the things that come out of nature, into the things that benefit us, maybe frozen fish or something like that, right? So that things can either influence us directly, right? I breathe clean air. There's no human product that I just benefit directly, whereas other things, say an agricultural product, there's a variety of processes that might go through where humans then turn those natural products into human-produced products, right? And in the process of doing so, we create feedbacks that then affect the structure, function, and composition of ecosystems, and hence we have our nice little coupled system. And when we think about values, again, this is just a simple typology, kind of the way economists think about values. We generally split the total value, and again, when we're thinking about values, it's just things that make people better off. And we might measure these in dollar terms, but we might not. We can split these into market values. These are values related to things we buy and sell in markets. Gallons of milk and little red wagons and automobiles, right? These are all market values. And non-market values. This is everything else. This is the value that we get from breathing clean air, from looking at a nice view of open space, going fishing for recreational fishing, all those things. Seeing if I go birding and see birds flying around, all those things are non-market values. We can further split non-market values into use values. These are values that I receive from some action, doing something like going fishing or drinking water or say even cutting down a tree to use for timber. Those are use values. Things that I can observe, actions that generate value. Non-use values are a little more difficult to think about, but these are things where I'm just better off, for example, knowing that something exists. I feel happier knowing that there are polar bears up wandering in the Arctic. And if I had a choice, right, if I could go and pay to ensure the preservation of polar bears, I mean, I can't do that, but if I could, I would do so, right? I feel better off just knowing they're there, and if they were to cease to exist, that would harm me. I would feel much less happy, right? That's an existence value. The quest value is I value something because I want to pass it on to future generations, my children or other children. And altruistic values would be I value something not for my own well-being, but because I value the fact that other people can enjoy that thing, right? So why do some people donate money to help nourish people in less well-off countries, right? Well, it's because we value the fact that these people can now eat and are healthier, right? So that's an altruistic value. So just a final little background slide. When we think about economic values, again, how do we think about it? First, values really to an economist is just an observable trade-off. It's what we're willing to give up to get something else, right? I can't see how happy you are or how well off you are, right? So as an economist, that we can't measure that. But what I can see is how much you're willing to give up to get something else. And that tells me a little bit of something about how much you value it. So for example, if you're willing to give up 10 pounds to get something versus 5 pounds, well, the thing you're willing to pay voluntarily, willing to pay 10 pounds more Well, we can say, well, probably you value that thing more than if you were only willing to pay 5 pounds for, right? So, and you can measure that trade-off not just in money, but in other things. The idea is the more you're willing to give up voluntarily to get something, probably the more you value it, right? That's kind of that's the trade-off that we're looking at. Values are only meaningful for well-defined changes from a known baseline, right? So in other words, for a value to be meaningful, I have to know where I start and I have to know where I end up, right? So if you go to buy something in a market, right, say you go to buy some milk, right, well, you have to know exactly how much you're going to get, right? Well, I'm going to get a liter or I'm going to get 2 liters, right? I mention that because a lot of times in ecosystem services, we've had cases where people have tried to value all the ecosystem services in the world, or what's the value of, of all the ecosystem services in New Jersey or something like that. To an economist, that's not a well-defined value. That would kind of be like saying, what's your value for all the milk in the world? Well, to most people, that's not a meaningful thing. You can tell me how much you'd be willing to pay for a liter of milk, right? Because that's a well-defined quantity, right? And so we're always thinking about where do we start, what's the baseline of the ecosystem, and where do we end up? And that enables us to value something, right? And then finally, our ecosystem services, again, to an economist, are always related to effects on humans. So, for example, non-use values are economic values. I can value an ecosystem myself simply because I want to preserve it the way it is. But an intrinsic value, right, a value that an ecosystem holds by itself, apart from humans, right, whereas the ecosystem itself has a right to exist, that may be a value, but it's not an economic value, right? And so that's something where, and I mention that because it's something where ecologists and economists often, they're often using similar words to talk about different things. And so I just mentioned that quickly. Okay? There are a lot of different ways we can measure values, right? So, and I'll just mention some of these. We're going to talk about one of these today, right? So first we think about revealed preference methods. These only measure use values. In other words, activities associated with things people do, with observable activities. And the reason is that revealed preference methods measure values based on observable behavior. So, for example, we have recreation demand models, which is where we look at where people choose to recreate, and we statistically analyze that with respect to environmental quality measurements. So we watch where people choose to go fishing and how far they travel to get there, as affected by aspects of ecosystem services, fish abundance, and other things at those sites, among other influential factors, and we use that to estimate trade-offs. How much more are people willing to spend or give up to get to a site, for example, with greater fish abundance? Hedonic property value models look at the relationship between how much people are willing to pay for a home and, for example, levels of environmental quality or ecosystem services in that area. People are, for example, are often more, they value living in a place more if that place has good scenery or clean water or clean air. And we can look at patterns in property values to ascertain, in other words, what people are willing to pay for a home as a way to measure those values. Right, so there's a variety of ways that we can look at what people do, right, patterns in their behavior, to estimate or to try to figure out what these ecosystem service values are. Challenges with revealed preference methods, because we're observing behavior, we can only measure values that are related to behavior, use values. Stated preference methods are what we use to measure both use and non-use values. Remember, non-use values are values, for example, for the pure existence of something, apart from any direct use that I might have. Stated preference methods are our survey-based methods, right? And the one we're going to talk about today is called what we call discrete choice experiments. And you can think of discrete choice experiments as effectively mimicking or modeling what people might support in a public vote, or like in the U.S. in a referendum, where people go, in communities in the U.S., for example, people will often be asked to vote on referenda to support various projects like farmland preservation or open space preservation, or to build a water treatment plant. And they vote, well, I will pay a certain amount of money, or I won't, in, say, increased taxes to support this project. And the discrete choice experiment takes that same idea, but does it in a way that provides more information about what people's values actually are. And I'll show you an example in a minute. Benefit transfer is just down here at the bottom. Benefit transfer is simply where we want a value for a particular site where no study has been conducted. But maybe we have a valuation study that's been conducted at another site that's similar. Well, benefit transfer is the process whereby we take the value that we've measured somewhere else and adjust it or move it over to a policy site where we need the value, right? So benefit transfer is kind of like secondary data valuation. Okay, so regardless of how we go about it, right, one of the things that distinguishes ecosystem service valuation from other sorts of things that other sorts of valuation that economists might do is we have a strong focus on both the ecological production side of it, what the ecosystems are doing, and the economic value side of it. Right? And when we think about ecosystem changes, you know, say in the case later on, I'm going to be talking about riparian land, a lot of different things change. And so one of the things that's hard to do is to figure out of all those things that's changed in an ecosystem, how do those translate into a discrete or reasonable number of things that we can actually estimate values for, right? Because when you go out and you say, okay, we're going to restore riparian lands in south coastal Maine, there's no book that you can go to that'll say, oh, well, here are the different ways that that influences people. There's all sorts of ways. And so you have to figure out exactly, once you've restored that land, so you need the ecologists to tell us, well, what's actually going to happen, right, when you say reforest that land. Once you figure that out, then you've got to figure out how all those ecosystem services will affect different people. Then you've got to figure out how to go about and value those changes. Right? And so this is hard. While we've got all sorts of work in ecology, all sorts of work in economics, we have less success, but we have less practice, let's just say, in terms of tying those two things together. There's some people doing lots of excellent work in this area, but there's also we're still learning as we go. Okay, so again, when we're thinking about ecosystem service valuation, going in, what we want is we want to obtain precise and measurable ES, or ecosystem services, right? That's on the ecological side. So we have to be able to measure what's going on. So we can say, well, before I can talk about what an ecosystem service value is, I have to be able to measure or forecast what's happening in nature. Then I have to be able to link that to a consistent and comparable definition of value. So I have to link that to a well-defined economic model, right? And then I have to link those together. Right? And so again, I already talked about how this requires attention to the ways that ecosystems affect people. And as an economist, we think about that as being analogous to inputs versus outputs in production models. So imagine that you're buying an automobile or buying a car, right? When you go to buy a car, you think, okay, well, how big is it, right? How fast does it go? How fuel efficient is it? Those are all the things that affect you directly. But if you were to go into a showroom thinking about buying a car, and I were to tell you, well, it took 200 hours of time to build this car, and there are 100 pounds of plastic that went into this car, and it took so many kilowatt hours of electricity to make this car, do you want to buy it? And probably you'd say, well, that's great, but those are all inputs. That's how the car was made. But that doesn't tell me the thing that I care about, right? What I care about is it comfortable, how fast, all the things, all those final outputs, right? So that's kind of that's how economists think about ecosystem services, right? So it's not enough just to say how much nutrient processing is happening in a wetland. That doesn't tell me anything about how people value it. I need to know what's coming out of that nutrient processing that people value. And that's often the challenge. Right? Because a lot of times, and so what we have to think about is, a lot of times ecologists or biophysical scientists will be doing a lot of measuring and monitoring, but if they're not measuring and monitoring the things that value to people, there can be this great body of ecological research that's not very useful when we're trying to measure ecosystem service values. And you can talk about a parallel thing in economics, right? You can have lots of economic research that doesn't link well to ecology. Right? So it's not it goes both ways. Right? So that's why we think about is what are those final things that value people. right? And if we don't pay attention to this, right, you can get value measures that it's really hard to interpret, right? On the economic side, what we tend to do is sometimes we can't, as economists, we're not used to measuring things on the ecological side. So what we've sometimes done is done valuation surveys where we've measured things in fairly crude units such as high, medium, or low, right? So what would you be willing to pay for high biodiversity compared to medium biodiversity? And people will answer those questions. But then from an ecological side, the question is, well, what does that really mean, right? What does high biodiversity mean? And when you talk to ecologists, sometimes they'll say, well, I don't know what that means. And so then we're in the uncomfortable position of economists as saying, well, high biodiversity is this, but ecologists are telling us they don't know what that means. And so then we have to argue that somehow a layperson, a non-expert, knew enough about that to value it, but a trained ecologist doesn't know what it means. So again, we have to be careful on both sides, right? So as economists, we have to make sure we're measuring values for meaningful ecological things that we can measure. But on the ecological side, as economists, we need to be able to obtain measurements that correspond to things that people value. Right? So, onward. Right? So we've already talked about this, right? 3 different ways that things can affect people. Can either have a direct or final effect on people, right? That affects people directly. No other biophysical processes have to intervene, right? We've already talked about this. An outcome can have an indirect or intermediate effect on utility, right? That's things like nutrient processing in a wetland, right? Or another example would be the amount of oxygen in a lake or in an estuary, right? It's not the oxygen that people care about directly. It's the things that the oxygen supports, different types of life, aquatic life, right? So the amount of oxygen in a water body would be kind of an intermediate outcome. And you can also have things that affect us both directly and indirectly, right? So for example, fish abundance, right? I may care about that as a recreational angler. That's a direct effect. There's more fish, so I can catch more fish. But that also, those fish may also support healthy bird populations, and those bird populations may be valued by people who like to watch birds, right? So fish populations can provide both direct and indirect services, and that's actually probably the most common thing, right? So that you have things that can affect us both directly and indirectly. All right. So we've already talked about this, so I'm going to skip through that. Okay, so what I'm going to do now for the rest of the time I've got is to actually use an example to show how we tried to do this stuff, right? So at this point I've just been saying, boy, all this ecosystem service valuation is difficult, it requires all these connections, blah, blah, blah. What I want to do at this point then is to say, well, okay, how do you do it, right? Taking an example, how did we start with a group of biophysical scientists, a group of economists, and how did we actually try to figure out what these values are? And the case study I'm going to use is from a case study of riparian land restoration in south coastal Maine, USA. I'll show you a little map of where that is. Some of you may know where that is, some may not. And we're going to be estimating economic values using discrete choice experiments, these voting type survey questions, and I'll show you what some of those are. And the project objectives, we were working with this project with the Wells National Estuarine Research Reserve. These are research reserves that are primarily natural science entities that are designed that are tasked with the conservation of estuaries, but also measuring scientific processes. So they're primarily groups that do ecological and biophysical science. So they have this great body of this rich history of ecological monitoring and measurement data that they've been doing for a large number of years. But traditionally, these groups and their various estuarine research reserves around the United States, they haven't worked with social scientists or economists to figure out how all that ecological data they've been collecting is relevant to people. So that's what this project was about taking all that great ecological data they have and trying to figure out whether we can link that to an ecosystem services framework to try to estimate some values. So we're going to be looking at the case study we're focusing on is the value of ecosystem services resulting from riparian land restoration. And what I mean by restoration is basically reforesting riparian land that's been cleared, right? So there's a lot of riparian land in the area, not a lot, but a fair amount that's been cleared for lawns or for homes or for other things, right? And so one of the initiatives that this research reserve is involved in is in trying to conserve the riparian land that remains. And actually it's a fairly natural area, so about 90%, or actually about 85% of the riparian land is still in naturally forested condition. But they're trying to maintain that and, if possible, restore some of the riparian land that's been cleared to a natural forest canopy. Right? And so that's what they're after. And the goal of the project was to provide information to help stakeholders, including landowners, including policymakers, to really understand what the ecosystem service value trade-offs would be, right? Because these projects would be expensive, and they want to know, well, how would people benefit from reforesting this riparian land? What would we get out of it? And also, what are the trade-offs? What is it that people value most? One of the reasons why this is so important in Maine is because this area of Maine traditionally, or at least the perception is, that they're very hesitant about land use regulation, right? That area has a fairly strong culture of private property rights. And so at least if you talk to policymakers, they'll tell you that people don't want to see more land use regulations. And so this was an important project in that we were trying to demonstrate or to evaluate whether there would be economic values coming out of reforesting this riparian land, and at the same time, to what extent would people be willing to accept greater land use regulations to get those benefits? So that's another side. So it's not just a money trade-off here, it's a regulation trade-off, right? It's to what extent people would be willing to accept greater regulation of their own private use of their private property in exchange for improved ecosystem services coming out of rivers and the surrounding lands. So this is where we're looking at, right? This is a map. Oops. How can I get this back now? I pressed the wrong button. Let's see. Next one over. There we go. Okay. Thank you. So here we have the state of Maine way up in the northeast corner where the little star is. That zooms in here. Down at the bottom, you can see that little red box, right? That's south coastal Maine. And then you zoom in even further. You see the Maryland, Branch Brook, and Little River watershed. And that's where we were. So it's a little tiny watershed. And the Wells National Estuarine Research Reserve is right there on the coastal portion of that watershed. Okay. So the project components, it was a 4-year project. First, we began research with decision makers, stakeholders, and the public to develop the models and identify the final ecosystem services that we were looking at. So asking how people understood their local rivers, what did they use them for, what made them decide, for example, where they might choose to buy a home, all sorts of actions we were after, and also just what is it that they valued about these waterways, right? What is it that, if push came to shove, right, if they were able to vote for policies that would restore or not restore these watersheds, what are the things that would help them determine how they were going to vote, right? And that was what we used to try to figure out what those final ecosystem services were, and also what the intermediate services were. From there, what we have to do is to coordinate our ecological and economic models to try to figure out how we can first measure those things that people care about, and then how we can link that to our economic discrete choice experiments that we're going to use to measure those values. We then had a stage of ecological field work to actually try to measure what the conditions were, right, to get those baselines and to try to forecast how they would change, right? So, for example, one of the things that people told us they cared about was the abundance of recreational fish. So we had to figure out, well, what is the current abundance of recreational fish in the watershed, and then how might that change if riparian land were to change. So that involved a bunch of electrofishing to come up with baseline levels, then looking at correlations between riparian land cover and recreational fish abundance throughout the watershed, right? And so it's a combination of figuring out what it is that people value, then how we can measure it, and then how we can communicate it to people so that they can figure out how they might vote in these effectively kind of hypothetical election or hypothetical polls that we set up. Right. We then put those all into a large survey, which I'll show you, and then we test that. And developing and testing the survey took us about 2 years, right? And again, it's because people have to understand the ecosystem services and how we're measuring them in order to vote in a meaningful way. So there's a lot of information we're providing people. And as a result, you have to take a lot of time to test the surveys, go back to the drawing board, revise them, take them into another group. The way we typically do this is using focus groups. I'll talk about that in a minute. And then we finally combine everything at the end. Right? So again, we're using discrete choice experiments. Again, just as a review, these are survey-based methods that estimate values from respondents' votes over different policy options. So basically what we're doing is we're mimicking a public vote. And you might say, well, do people, okay, so this is, so we're basically setting up a hypothetical kind of referendum or vote over competing policy options, right? Would you vote for a certain restoration plan, A versus B, or would you choose no restoration plan? And I'll show you an example of this in a minute. And we ask people to vote over many different sorts of potential restoration plans. And by analyzing or by looking at how people vote for different types of possible plans, for or against them, we can look at the trade-offs they're willing to make. And again, I'll show you an example. Right? One thing you might ask, though, is, okay, do people really, you know, how do you know that people that those answers are real, right? I mean, so this is just a survey, right? Why wouldn't people just say, sure, I would vote to pay £1 million to restore this? Well, there's a little trick well, it's not a trick, but the way we design these surveys is according to a property called incentive compatibility. And there's a lot of pieces to it. But effectively what we do is, when we give these surveys, we develop them in concert with local policymakers, say local planners that are actually engaged in policymaking. And when you send the surveys to people, you say, well, you better be careful with how you vote, because we're going to take your answers and we're going to send them to the local government. And they're going to use them to decide what they're actually going to do. So if you vote, for example, that you say you really are willing to pay, you know, whatever it is, £300 in additional taxes to support this program, well, it's possible that that might actually happen, because we're going to send these to the people who are actually making policy. And what that does is it creates an incentive for people to tell the truth, right? Because if you really, you know, because if you lie, right, if you say, well, I'd be willing to pay, you know, extra taxes to support this program. Well, that might actually happen, and it might come back to, you know, to haunt you later on, right? So by linking this to the policy process, even in an indirect way, it provides a strong incentive for people to tell the truth. And what we've done is, and we could talk about this later on, we've actually compared the results that you get from these surveys to results that you get from parallel public elections that have been held later on. And by and large, they line up very, very closely, right? And so what that tells us is if you do these surveys well, people in fact will vote the way they actually would vote in a binding election. If you don't develop these surveys well then who knows what you get. But okay, this is just a quick illustration of how they work, right? So this is a simple conceptual framework. Imagine that you have two potential voting options: the status quo with no new policy, where X1 and Y1 are the baseline quantity of two ecosystem services. Since this is status quo, there's no change in your annual household taxes. And so you might ask people, well, would you vote for the status quo, the way things are today, or would you vote for a new policy option, right? So say policy option A would add a little bit to some ecosystem service Y. You'd add A units to it, whatever that is, and say it would increase your taxes by $10 a year. Well, if someone votes for that, effectively, and if they're telling you the truth, what you can infer from that is that adding A units of ecosystem service Y is worth at least $10 to them. Otherwise, they wouldn't vote for it, right? So this is just a real simple illustration of how these things work. The real questions are much more complicated, but that just gives you an idea. So we developed a discrete choice survey over 3 years, lots of collaborations with scientists and stakeholders. Focus groups and interviews. Focus groups are just a discussion with, say, a group about the size of this one, where in the beginning we just talk about the local rivers, how you use them, how you value them, what are the things that you value directly about them versus not value directly about them, right? And then later on we use focus groups to test out the survey. So I give you a survey, I have you take it, then I have you talk through it, how you answered the questions. I then use that to understand what you understood, how you answered it. Are you understanding the questions the way I am as a researcher? Do you understand the information? Is anything confusing about it? We then go back, take your input, redo the survey, correct things, take it into another focus group, test it again, over and over and over again. And in this case, that over and over and over again took about, again, close to 2 years. So if I were to show you the first version of the survey compared to the survey I'm going to show you in a minute, there's almost not a single word that is the same. Everything is different, right? And so so I'm always a little bit hesitant of kind of a survey that was developed in one day on someone's computer, given how difficult it is to develop these kind of surveys, at least in a lot of cases. Right? And so the idea is that these choice questions that you're going to see are grounded not only in the focus groups and interviews that tell us what people value, but also in the ecological field work that actually quantifies the changes that we're going to measure. Okay, and so the process that we used, again, the focus groups combined with the ecological field research, generated 7 final methods and outcomes of riparian land conservation that were most valued or most salient to the public. There were little things that were valued by certain small groups of people, but in terms of things that people valued most, the primary value first was just natural vegetation cover in a riparian land, just how much of it was there. This was largely an aesthetic thing. People just like to see nice trees by rivers, right? They don't want to see them all cut down. Water quality and ecological condition, and this was measured using an aquatic biotic index. Basically, this is more than just water quality. It's essentially the health of the local waterways. And this was largely based on what we would consider a non-use value. This was just people wanted to know that their local rivers were healthy and supported life. And it was kind of a more holistic sense. Right, so this wasn't really a use value thing because these parts of the river weren't, it's not that people were swimming in them. Most of them are on private property. You can't get to them. Recreational fish abundance, this was measured using index of brook trout abundance. This was something that was largely driven by recreational use. People want to catch fish, right? And so they said, well, brook trout was one of the major fish that was harvested in this river, that was caught. And so we had an index of recreational fish abundance to measure the effect of riparian conservation first on the health of rivers and then on fish. Right? Swimming safety of local beaches. These are downstream, right? So riparian land prevents nutrients from entering the water. That then doesn't go downstream. And so the local ocean beaches nearby, we actually have beach water quality tests. So we have a record of how many tests have passed swimming safety regulations or have said, well, this is safe to swim. And we know how many haven't. And so we can use that to measure the potential effect of riparian land restoration on the safety of local beaches for swimming. Turns out that while we can look at that hypothetically, it's actually very difficult to forecast that because it's such an indirect effect. And then development restrictions. Okay, so here we have our kind of causal linkages, right? So we have funding to support direct restoration activities. We have development restrictions and enforcement. These are what people are and are not allowed to do. The immediate effect of that is on natural riparian land cover. That affects recreational fish both directly because, for example, fish, if you have natural cover, they can hide under the fallen logs and things like that. It also affects water quality and ecological condition, which also affects recreational fish. And then this affects downstream swimming safety. So we have our nice little causal linkage. But these are all the so for example, water quality, when we present that, because we're presenting that and recreational fish, we can allow people to understand what the final effects on both of them are. If I were to have not presented recreational fish and just presented water quality, well, then people might have speculated about or made a best guess about what would happen to fish. So I have to present fish as well because otherwise people might guess at what that is, and we don't want that to happen. Once we have our attributes or our things that are go into the survey, we have to measure them. So this, I'm going to go through this relatively quickly because we're running out of time. But this just shows how we actually calculated the amount of riparian natural land cover that was on riparian land. We basically went in, we drew circles, and then we came up with polygons of cleared versus uncleared land, and then counted that up over the watershed. Right? So this is the survey that came out of it. And I'm going to go through this relatively quickly. It's not all pages of the survey, but it just gives you an idea what it looks like. Right? So we start out with a page that explains to people what riparian land is and why people care about it, what it does, what ecosystem services it provides. We then go on to show them the area we're talking about. This is a map of the watershed, the Maryland, Branch Brook, and Little River, and those little brown areas, those are the rivers, and this is the exact riparian land that we're talking about. So we show them exactly where we're talking about making the changes. We developed this little diagram to show them exactly what riparian land does, because this survey is going out to just regular untrained people, right? So we discovered that we had to give them a lot of background information to explain why it was that we were talking about fish changing as a result of reforesting land, right? Some people understood that right away, but for other people we really had to explain. So we had an artist develop this diagram for us to help explain to people how it was that riparian land functioned, right? We also show them illustrations to show them exactly how we measured the changes we're going to show, right? So one of our attributes was something called natural riparian land. This was a measure of an ecosystem service. And here we have this diagram on page 4 that shows exactly how we measured that and what it meant when we said that riparian land was 100% natural or 25% natural. So we show them exactly what we're talking about, right? We then say, well, here are the ways we're going to, these are the different effects we're going to talk about. Natural riparian land, river ecology, recreational fish. So we start out by giving them in just simple terms, right? No details. Then we go on to a next page. It gives them all sorts of details, right? So we start out simple, right? And then we go more complicated to tell them, for example, for natural riparian land, it's the amount of riparian land covered by natural vegetation. Currently, about 91% of the land is in natural condition. With no action, 85% of the riparian land in the area, about 4,000 acres, will remain in natural condition in 5 to 10 years. So we tell them the way it is now. Also, we presented both in cardinal terms, number of acres, and also in percentage terms relative to the ecological reference condition. In other words, relative to the best it could possibly be. So for riparian land, 100% would mean everything is forested. Everything is in natural condition. We're at 85%, right? So for recreational fish, 100% would be the most possible brook trout that that area could support. And I'm going to go through this relatively quickly because, again, we're running over. This is an example of a choice question that they're looking at. And so you can see basically they choose, here's the status quo, right? This is the way things will be in 5 to 10 years if we don't do anything. A is one possible option for change, right? In this case, it would involve a $45 increase in annual taxes and fees. And up above, you see the potential changes in ecosystem services. Option B is another potential option. And then we go on to a set of questions. Each survey included 3 of these, and there were 24 unique versions of the survey. So actually, in total, there were 72 different versions of these questions. It asked people to look at many different possible ways to restore the watershed with different effects on all of these attributes that we call them. And by looking at how people voted yes or no for all of these different effects, we can evaluate the trade-offs they're willing to make, both between money and these environmental effects, as well as between, for example, are they willing to accept greater development setbacks? Setbacks are areas where no development is allowed, right, on their private land. Or are they willing to accept more enforcement? In other words, people coming and making more inspections on their private land to make sure they're following the rules, right? So they answer a bunch of questions. We then ask a bunch of follow-up questions, such as, did the survey provide enough information for you to make informed choices? And so here we have some answers to our debriefing questions, right, just to give you an idea, because a lot of times people look at these questions and go, wow, that's really difficult. Could people really answer that question? And so we ask these questions at the end. For example, I feel confident about my answers, right? And as you can see, most people either agreed or strongly agreed, and very few people disagreed or strongly disagreed. So that's kind of the way we gauge, or one of the ways we gauge, did people get it, right? Because people, are people totally confused, right? Here we have another question, would you vote the same way in a public vote, in a real public vote or referendum? And again, most people either agree or strongly agreed. Very few people disagreed or strongly disagreed. So again, that's a way that you can kind of get a gauge, because if people don't like something, they'll tell you, right? It's like all those negative restaurant reviews that you get online. If people hate a survey, you'll know. You'll get all sorts of spikes over here, right? Okay, so we sent out the survey, lots of people. We sent out about 4,000 of them. We got a response rate of, this is a mail survey, went out by postal mail. We got about close to a 35% response rate. So that's another good indication that, okay, if you don't do a good job with this surveys, for a mail survey where you just send this to people's house, well, this might be down around 5%, something like that, right? So we got over a third of the households we sent this to, just blind. I mean, these were just random households in the area, sent them back. So this shows where the surveys came from. Black dots are surveys that were not returned. Green dots are surveys that were returned. So this just kind of shows you where the spread. This area here in the middle, that little black line, that's the watershed. So we asked people in the watershed as well as outside the watershed. We actually oversampled the watershed itself. We sampled every household in the watershed, right? So because there weren't that many households in the watershed. Okay, so again, just details of the estimation, which I'm not going to spend time on. This is just a bunch of numbers that shows we really estimated the model. I'm going to whip through this in 2 seconds because for most people this doesn't matter. But the only thing I will say is that coefficient column, at least the top under random parameters and non-random parameters, these are just you can interpret these roughly as the weight that people gave to each of the attributes when choosing between choice options, right? So basically the fact that these are all statistically significant means that people paid attention to those on average, right? I'm going to whip through that. If you want to come back to that, we can. To turn these results into values, what we do is we calculate the trade-off between the weight that people gave to the environmental changes or the ecosystem services changes and the weight they put on the cost of the program. That ratio tells us the trade-off, and that, simply put, is just the value. And so here, these are interpreted as either environmental or ecosystem service values. These numbers on the top, right, for land, river, recreational fish, and swim safety, these are all denominated per percentage point change. So you can kind of compare them. You could also denominate these in acres and number of fish. But I like doing it this way because it kind of gives you a relative weight. And so here you can see that per percentage point, people put the most weight on changes in riparian land covered directly. And remember, because these things vary independently in the choice questions, these are interpreted as value for each of these changes, holding everything else constant. So this says that people are willing to pay $2.05 per household per year per percentage point of riparian land natural canopy in the watershed, holding everything else constant. So if nothing else changes. So to come up with a total value for a riparian land policy, you would then have to model out what would happen, right? So you get a certain amount of riparian land vegetation. That leads to a change in river quality. That leads to a change in fish. And then you'd sum up all those independent values to come up with a total ecosystem service value. Interestingly, if you look down here at setbacks and enforcement, right, notice that these are positive. This was a huge surprise to policymakers in the watershed. This says that people are more willing to support a restoration policy that has more strict enforcement on development or more strict regulation and restrictions on development. Again, holding everything else equal. So even if everything else is constant, people are more likely to vote for something that has wider setbacks, more restrictions on development, and more enforcement on regulations. This was, interestingly, exactly the opposite of what policymakers told us would be the case going in. When we went in and talked to the planners and talked to the elected officials in Wells, Maine going in, most of them told us that, well, that their opinion was that people would strongly reject any sort of policy that would involve more restrictions on private development. In fact, a lot of them told us that people would be so upset that, that we would get, phone calls and people get really angry about this. And in fact, we found the exact opposite. We found that there was strong support for greater restrictions on riparian development, which was a huge surprise. And it actually shows you how these can be how these results can be important, not just in estimating values, but in estimating things that people don't expect. Right? So just kind of interpreting these results, we find significant values for all the primary ecological outcomes, right? All of them have statistically significant values, but they're different, right? People value some things more than others, right? And we showed, for a relative basis per percentage point, values are greatest for changes in just the raw forestation of riparian land and for changes in swimming safety. We have smaller but still significant values for changes in river condition and recreational fishing. And results challenge a lot of prior assumptions of policymakers, right? So a lot of what policymakers in the area understand about public values comes from a small number of people who show up at public meetings and speak very loudly, right? And so this kind of shows a broader perspective on what public values are, right? So we get some surprising outcomes, right? Including the fact that that we have positive values for wider development setbacks and greater enforcement of existing shoreland restrictions. But also, a lot of people thought that the primary value of riparian land restoration would be on recreational fishing values, right? Most people just assumed that that would be the greatest value. And in fact, while it is positive, it's actually relatively small compared to some of our other values, our values associated with aesthetics, with non-use values. Right? And so that was another thing. A lot of times the ecosystem values that come out of these are not always what you'd expect ex ante. And so that can, again, it can be surprising. It can direct policy in slightly different directions. So finally, what I want to show you is different ways you can use these results to forecast the benefits that come out of policies. So first, you can do a whole bunch of what-if scenarios, right? So setting the ecological forecasts aside, you can just say, imagine that you had a policy that had these effects. What is the value that comes out of it? Right? So that's one thing you can do. You can also use that to forecast how people would vote for or against different things in a purely what-if scenario. Right? Imagine that you had a riparian land restoration program that had these effects on the natural world. What would be the value in votes? But what you can also do then is go back to our ecological results and say, imagine that you were to reforest a certain amount of the watershed. What is that predicted to do to ecological condition, to fish, to swimming safety, and use those predictions to come up with a value, right? So it's two different kinds of forecasting. So I'll just show you a what-if scenario. This just says, imagine that, here's our status quo. This is no change. And this negative value, this just says that this is just a value that people, in this case, said that they really didn't want to do nothing, right? And if you look at their votes, it turns out that doing nothing has a huge negative value for them just because they don't want to do nothing, right? So that's not really an ecosystem service value. That's more just a rejection of taking no action. Here, the 1024 and 2174, these are kind of what we would consider true ecosystem service values. And so, for example, option A says, what if the only thing you do is you change land condition from 85% to 90%? Okay? Well, and nothing else changes? Well, that generates an added value, ecosystem service value per household per year of about $10, right? If, in addition to that riparian land change, you change recreational fish from 55% of the reference condition to 65% of the reference condition, well, now your total ecosystem service value jumps up to about $21.74. So now you can say, okay, how does ecosystem service value change when different things change in ecosystems, right? So this is just what if. Just imagine that you had these two plans, what would be the value that would emerge? And you can also look at how people would vote, right? So for example, let's just look at option A. Say you had a referendum where they can either vote for no change, the way things are today, or you say, well, you have a policy that will get you 5% more of the land in the watershed reforested. That's going to cost you $25 a year. What percentage of the people would vote for it? It turns out that the predicted vote would be about 64.5% in favor, right? So you can actually predict how people would vote. And it turns out that when we've tested these in other circumstances where, later on we've actually given people a chance to vote, that these actually predict real votes almost exactly. And I can give you an example of that later on if you'd like. Okay, really quickly. You can also, instead of just doing a pure what-if scenario, you can also model out what would happen. So for example, in this case, we have a positive relationship between forest canopy, natural riparian vegetation, and fish biomass, right? So that's in this left-hand column right here, right? And so this just shows the regression line. And what you can do with that is you can use that to estimate that an average 1% increase in riparian land tree canopy is associated in the watershed with a 2.47% increase in brook trout abundance. So that's just based on correlations we see in the watershed. Right? So what you can do then is you can say, well, let's imagine that we did have, so let's imagine we engage in a policy that restores 5% of that riparian tree canopy. Assuming this observed relationship continues to hold, that would lead to a change from 55% of the reference condition for recreational fish to 67.35%, right? So that is the predicted change that we would get in recreational fish. Now we can use, and it turns out that that we couldn't predict any change using the ecological field data that we collected for the project. We couldn't show that there'd be a significant change in river condition or in swimming safety. There were positive relationships, but they weren't statistically significant. And if you talk to the ecologists, they'll say that probably it was because of sample size. They just didn't have enough sample sites. But we can't, we can't establish a significant change, so we're going to say there's no change there, right? So you take so you take a change in a riparian land condition, that leads, or that's forecast to lead to a certain change in recreational fish. Assuming that our setbacks and enforcement don't change, now we can predict the ecosystem service value that comes out of that. So now we're putting everything together and we're using the ecological relationships that we actually measured to predict what effects are going to happen. And then we can use our economic results to predict what values would come out of it. Right? Okay, then just really quickly, right, so there's a bunch of challenges, right, as you might guess, right, because we're relying both on ecological and economic field data, right, it means that there's a lot of time and effort that went into this project. It was a 4-year project, right, because not only do we have to build a survey, we had to do all this modeling and measuring on the ecological side, right. We also, from the very beginning, right, had to line up what people cared about with what ecologists could model and measure. And in some cases, we just didn't have the sample size to evaluate some of the biophysical patterns that ecologists expected, right? They really strongly expected to see a change in river condition and water quality associated with changes in riparian land. We put that into the survey, assuming that we would find that change, right? And we modeled out what that could be hypothetically, but then they couldn't find a statistically significant pattern, right? So again, what do you do with that, right? And that's something we're working through right now, right? And so again, when you're thinking about these results, you really have to interpret them with respect to both the values that people have, but also the biophysical changes that you can really argue or kind of demonstrate will happen. And then finally, okay, last slide, and I apologize, I've gone way over. A few just kind of final take-home points. One of the things I like to highlight about this project, we're in the final stages, is one of the things that makes it nice was involve detailed, extensive involvement of both biophysical scientists and economists from day one. We were all working together from the outset of the project. This wasn't something where a bunch of ecologists got together, did their whole project, and then talked to Nick and said, Nick, we need a value for this, or Rob, we need a value for this. And it wasn't the opposite. It wasn't a bunch of economists who had a project and then went to an ecologist and said, oh, here, we'll pay for 2 weeks of your salary. Give us the data we need, right? It was something where we all worked together from day one, right? So it's a fundamentally coupled approach. Everything was developed in tandem. All right, the ecologists measured the things that we needed measured. We valued the things that they were measuring as well. And again, the goals of values that are well defined from both an economic and an ecological perspective. And as a result, what we can do is we can track the values all the way back to changes in riparian land, to effects on at least the verifiable ecological changes that we can verify through our economic models. The values are linked to easily measured indicators. Everything that we have a value for, you can link back to something you can specifically measure. Brook trout abundance, you can measure using electrofishing. riparian land that you can measure using remote sensing data. Everything you can link to something you can see and measure on land or in the water. And the process, again, although we didn't talk about this very much here, we closely integrated the process with stakeholders and decision makers, planners, government representatives, elected officials, environmental groups. They were all involved over the 4 years to make sure not only that the values that we had were salient from a scientific perspective, but that they linked up to things that the policymakers were actually doing, that they were salient from a public policy perspective. So but that's another thing that I didn't have time to talk about. I apologize for going over, but that's the end. That's all I have. So happy to take any questions that people have.
Thank you very much, Rob. So I think there's some people listening online that are going to ask questions.
And I don't know how to pull up the question box or
Well, we can take some questions to people in the room, I guess. So I know some of you are not economists, and some of you are, so we're happy to take questions. Who wants to
yeah.
Sarah?
Okay, yes, in the back.
What do you know about which really successful sector? Were they represented?
We're the 34% representative, yeah. What we typically, so the question is, how do you I think what you're asking is, how do you determine whether that 34.5% is representative of the population, or are they just, for example, do only environmentalists answer the survey, or something like that? Is that the question? Right. And so the answer is, how do you determine whether the people who responded to the survey are representative of the population, or do they tend to skew older, more educated, what have you, or whatever? Right. And so we've done a couple things thus far. This is an ongoing project. The first thing we've done is you can just do a quick kind of mapping of the sample you get versus local census data, right? So you can look at the breakdown of age, education, income, what have you, against what you have in the survey. And we've done that. And what we find is that we skew, and this is, as you suggest, common in these surveys, we skew slightly older, slightly higher education than the general population. I don't have the graphs here. Not a huge amount, but we do skew older, we do skew higher income, we do skew higher education. Once you've done that, though, what you can do, if that's the primary source of your non-representativeness, you can effectively reweight your analysis, right? So basically what you do then is you'd give slightly greater weight to responses from the younger folks who have answered, right, or to the less educated. And so you can balance out your analysis so that you get results that are representative. That's easy enough if any non-representativeness is just related to things you can see. It's slightly harder if it's related to things that are harder to see. Like, that people who tend to care more about the environment answer more. In that case, there are a variety of more complicated things you can do. What we do in this case is we ask a number of questions that are designed to evaluate to what extent people answering the survey tend to skew more environmentalist or more, say, pro-development. And ideally what you can do is then you can compare that to broader indicators. The other thing that you can do, and this is just totally casual, is you can look at the comments that you get at the end of the survey. We have a big page where we ask people to make comments, and you can tell by the comments that they write whether they tend to be pro-environment, pro-development. And I've asked my graduate student to take an initial look at that, and at least at our first cut, it seems like it's pretty balanced. And we do ask some indicator questions at the beginning that say, well, do you favor more restrictions on riparian land development? And so we do all that to try to get a read as to whether the survey is being answered primarily by, say, people who care about the environment more than other things. And in general, on that side of things, again, we're at the beginning, seems to be fairly balanced, right? We're getting opinions on both sides, but we're still kind of working through kind of the fine points of how we're gonna if and how we're going to adjust that in terms of the final numbers. That's a good question. Other questions? Okay, so nothing more from the room. All right, so on to online questions. We have one question that says, I'm just going to read it. Was the difference between what people expected and what the survey concluded around regulation because the survey allowed people to better understand the implications of land cover change for benefits, knowledge which they normally wouldn't have? That's a fantastic question. And the answer is, well, the short answer is that we don't know for sure exactly why we found the difference in values. And by the way, that question came from Mary Christie. We just know that it happens. But I can give you some anecdotal responses based on the focus groups that we used to develop the survey. And these focus groups were, the initial focus groups were held with respondents before we provided them with any information. We just brought in random people. We paid them typically about $75 to come in and talk to us for 2 hours about their local area. Right? We didn't tell them that this was about environmental conservation. We just said we would like to talk to you about policy in your local town, and we will pay you $75 for 2 hours of your time. And so we get a total random mix of people. And what we found based on those focus groups was much more support for regulatory restrictions than we expected. Right? And again, that was before we provided any information. So based on that qualitative input, and admittedly small sample, you can't kind of generalize it in the same way you can statistical data. My expectation is that a good chunk of that difference is simply due to the fact that the information that the policymakers and elected officials were gaining were based on a very small sample of people who cared very, very highly about development restrictions. Often these were landowners who wanted to, for example, put in a shed or clear land, and so this very small sample landowners comes in frequently to town meetings and effectively makes a lot of noise. And they provide perhaps a misleading perspective that the broader population rejects these restrictions, when in fact most people who don't show up to the town meetings would prefer to see more of these regulations. It's also possible that this was affected by the information that we presented in the survey. And one of the big questions that people ask in these surveys is, well, how do we interpret this? Because this survey that you just showed us, people received a lot more information than a normal person would have, right? And so does that truly reflect the value of average people? Because now, in effect, you've educated them, right? And that's an excellent question. And the way we interpret it generally is to say that, well, any time in economics, for people to make good choices that reveal their values, they have to have good information, right? And if you, even in a market, right, if you go out and you purchase a product, right, based on bad information, right, say I go out and I drink milk because I think if I drink milk, it's going to make me, you know, much more handsome, and it's going to, you know, take my time, my race time in the 5K, and it's going to make it half, you know, it's going to cut it in half. I mean, obviously, that's not good information. And so what I'm paying for that milk isn't going to reflect an accurate value, because when I drink that milk, it's not going to have those effects, right? So that's why in markets, we put in things like nutrition labels on food, because ideally that enables people to make better choices that reflect their values. So this is the same thing that I interpret about the value that the information we present in these surveys. It's like a nutrition label. It enables people to understand the effects of what they're voting for on them, and therefore better reflect the values that are inside them. But that being said, that's one of the reasons we have to be so careful about developing these surveys, because obviously if you skew the information in these surveys to try to to make environmental preservation look really, really wonderful and to downplay the cost, well, obviously you can skew people's values up if you want to, right? So what we try to do very hard in these surveys is to present a balanced perspective, right? The pros and cons of whatever you're talking about, so that people can make a reasoned, valid judgment that reflects the values. What we're after is the values, the increase in people's well-being that they would actually get were this restoration to happen, right? And so that being said, in order to give us responses that reflect that, people have to understand what would really happen were this restoration to occur. If they don't understand that, then the answers they give us aren't going to reflect what their values might be, right? So that's where I'll stop, unless anyone has a follow-up on that.
I have a question, Robert.
Yes.
Or maybe it's another question, but just while people are thinking. There are actually two questions. One is that in this case, you get a really nice link between what it is that people are able to value from your survey and what the root cause scientists, the ecological, are able to measure. And there's a kind of a fairly simple story you're trying to explain to people, which is that if you restore this vegetation, things get better.
Right.
And the things that get better are things that, on the whole, you know about. You know, like those things, you can see the landscape, and you probably care about. But that's because this is a sort of local public good.
Right.
Whereas many times what one is trying to do in doing this ecosystem evaluation stuff is deal with contexts where it's much harder to draw the link between what's changing if you ban fishing over here or if climate change is like that over there. So the things that change, and the ecologists can talk about it, and the things that people value. So making that link is much more tortuous in many cases. And it may actually be something that's pretty far away in space from the effects that would finally be observed. So I just wondered if you had some view on whether this was like almost the ideal situation that you had got here to show that this approach works.
So the question is, again, just in the microphone, paraphrasing is, in a sense, is this situation that I illustrated a relatively ideal case for ecosystem service valuation because it's a local scale thing. People understand the local area. We're valuing things that are easily measured, that are local, that people understand. And so it's really, so in a sense, it made it very easy for us to draw a link between the things that people were modeling and measuring on the ecological side and the things that valued. And people have experience with them. And so it makes it easy. And so the short answer is yes. Right, it is in many ways an ideal case, and that's one of the reasons why we chose this case study, because it allowed us to demonstrate a lot of these things. And the other part of the question was, well, what does this mean, or can you draw any implications for the more common case where there's a much more tortuous or indirect link between the things that we can model and measure as ecologists and the things that people might value. Say if you're talking about climate change or fisheries regulations where you're talking about effects far and wide. And I think the answer is that we've also done an approach like this, and Ed and Nick, I know as have you, where we've looked at things that are much more indirect, right? For example, I did a survey that was used to evaluate the effect of regulations on cooling water intake in power plants, right? Where cooling water intake in power plants, you draw in a lot of fish larvae and eggs, and that's the primary direct ecological effect. Then you have to model out what that means for fish populations, often very far away. And then you have to think about, well, what's that going to mean for commercial and recreational fish? Most of the effects are just on forage fish, and it's very, very difficult to, and a lot of these effects are quite small. And in that case, what we did was we did the same thing, and what we did was we had to include relatively small policy effects because that's all we could demonstrate on the ecological side. But but really what we had to do was the best we could do in terms of measuring this, and then just be honest about the fact that there was a great deal of uncertainty in these forecasts. And so I guess that's, you know, having no kind of magic bullet. That what I would tend to suggest is, obviously we can only base these on the best kind of ecological forecasts and data we have, but that we just be transparent about the uncertainty that is involved in those estimates. I guess where I have a little bit more question is where we present things that are very, very indirect and uncertain, as if they're very definite and certain, and because I think that potentially can be misleading, because if I'm thinking, well, there's going to be a 10% effect, when in fact, who knows, it could be 10% is the average, but it could be negative, negative 10 to positive 20 or something like that. But that's one of the things that I've been thinking a lot about, is how we deal with uncertainty in these things. So, but yeah, the short answer is this is a close to ideal case in a lot of ways.
We have another online question.
Yes. Question is, would a survey like this, from Robert Riley, would a survey like this help raise a referendum vote due to increased chance of success for a change of local policy? And if I understand this question correctly, the answer, well, the question is help raise a referendum due to increased chance of success. Well, it can. The best thing I can do with this is to tell a story. In that in one case, this was back in Rhode Island. There was a small town in Rhode Island in the United States, in New England, that was considering a new water supply system. Right, the water was on local wells, and it wasn't very reliable, and they were considering putting in a piped water supply that would have provided water, but it would have been expensive to the townsfolk. And it also would have involved ripping up their roads to put in these pipes. So it would have involved a lot of nuisance, but then would have provided a reliable supply of water. In order to do this legally in Rhode Island, it had to go through a public referendum, a binding vote. But to get that referendum on the ballot involved a lot of expense, a lot of time, a lot of effort. So what they did was they came to me. I mean, they heard that I did surveys like this. This was back in around 2001, and said, would you do one of these choice surveys, because we want to know how people would vote before we take the time and effort of going through this thing. At this point, nobody knew that a referendum could be coming, but before they even thought about it, they wanted to know. And so we did one of these surveys looking at how people would vote for or against this public water supply. And so what we did was we predicted that we predicted that it would lose. And we predicted that it would lose very narrowly. We predicted that it would get about 47 point something, maybe 47.6% of the vote, or 48%, I forget exactly, but it was right around there. And so we gave this to the Water Study Committee, and we said, well, it will not pass. And they then took that and said, well, that's great. We think it will pass. So we're going to take this, and we're going to put a lot of information in the newspaper to kind of pump up how good this water supply, and we think that's going to bump us over the edge, right? And so they did. They put a bunch of articles in the newspaper trying to highlight why this was good. They went through all the effort. They got it on the ballot, and it failed, and it got almost exactly 48% of the vote. So that was kind of nice for us, in that we got to say, well, we were correct. But so in that case, this survey did provide the foundation for a subsequent public vote. And it also predicted the outcome very nicely. And then there's the other question is, could this influence the result of a subsequent public vote by, say, providing information that would be relevant to people? And that I suppose could be the case as well, right? So, for example, if you in this case, the survey we used had exactly the same information that would go to the public vote, because the Water Studies Committee provided it to us. But it could be that you put this survey out, and by putting the information out there that people weren't aware of before, it could provide, new information that provides support for a public referendum that hadn't existed before. So there can be a variety of ways that it can interact with the policy process.
Brilliant. Do you have one last question?
Yeah.
That's okay.
The first one is related to the issue of uncertainty that you have just mentioned, and I was interested to know how you dealt with this issue in your study, if so. And the second one is related to the issue that you mentioned before, using the comparison of the scientific compatibility. Because I understood that you had just residents in the country. And so, did you face this challenge, also because I think it's a problem or a challenge, with non-residents? And so, how did you do that?
Those are two great questions. So the first question is, how did we deal with uncertainty? In this case, the way we dealt with it was we simply highlighted the fact that these were based, we didn't have explicit measures of uncertainty, and that we didn't have the data to provide, say, a probability density function, and those are very hard to communicate anyway. So we knew that obviously things were uncertain, and so this is what we communicated. We simply said, in the letters with the survey and in the survey and this is pretty typical of these, we simply say that these are based on the best ecological science. And in fact, the way we motivate the fact that we're giving people 3 different choice questions to vote on is that there are many different ways to restore, in this case, riparian land, and that the outcomes of riparian land restoration are uncertain. And so therefore, we're asking you to vote for different policies, recognizing that in many cases we don't know exactly what's going to happen and what are going to enact. So we use uncertainty in a sense to motivate the fact that we're asking people to look at different choices. But we don't, in this case, explicitly quantify uncertainty. There's another survey I'm doing right now looking at coastal adaptation, flood defenses, in Connecticut in the U.S. And there we're actually quantifying it, where we're looking at the probability of storms of different severities. So we're saying, well, based on historical patterns, here's the probability of storms, a Category 2 storm, a Category 3 storm. And then we're quantifying in our survey how many homes would potentially be flooded if a storm of that category hit, and then allowing those number of homes to vary. And so there we're explicitly looking at uncertainty. And we're also doing 2 different versions of the survey. One where we say, here's when the storms have hit most recently. And this is what meteorologists say in terms of the probabilities. It says that, for example, there's a 1 in 5 chance that there will be a Category 3 storm at least once by 2025. Another version of the survey, we're doing exactly the same thing. We tell them when the storms have hit, but we ask them what their subjective probability is. And the reason we're doing that is to kind of try to figure out what they're thinking if we don't tell them a probability. Because most of these surveys don't. We just say, well, here's what the expected value is. And what we're interested in is the probability that people have got in their head when they're answering the survey the same as the probability that people that the experts are giving, and does that influence their responses? And we're actually finding that it does, and it does in some pretty interesting ways. And that data just came in a couple weeks ago, so we're just kind of scrambling. So the answer is it's a really hard thing to do, and you can either do it explicitly or implicitly. And this is something where we say things are uncertain, but we don't quantify the uncertainty. And the second question is on incentive compatibility, the non-resident thing, and the short answer is it wasn't a bad issue here. The way that we dealt with it here was in terms of seasonal versus year-round homeowners, right? Because some cases there were a lot of summer homeowners. This is a beach community, and so a lot of people rent out their homes during the summer, and so we wanted this to go to primarily year-round residents, right? The people who paid taxes, because the seasonal residents don't pay taxes, so it wouldn't make sense. And so the way we dealt with it in this case was we sent it to basically the primary homeowner, not to temporary, not in this case. Seasonal renters don't have their name associated with that address, right? So by getting the particular mailing list we ruled out renters because we didn't want that. but we didn't have the issue of people for whom there was just no incentive compatibility. What we've done in the past, where we have had a very broad, say, a national sample, is we've defined the payment vehicle such that it's relevant to our sample, right? Because ideally, people, at least on the environmental side, right, either people have a value for it or they don't, right? And if they have a value for it, then you have incentives on that side, right? Because they value the environmental change. And so then the other side is do they view the payment vehicle as something realistic that they would actually have to pay? And so in that case, you just have to define your payment vehicle so that whoever is getting it, resident, non-resident, whatever, so that it would be something that they would actually have to pay. So if you've got a bunch of non-residents, you wouldn't define it in terms of taxes. Maybe you would define it in terms of, you know, a user fee or an entrance or something that everyone would have to pay. And that's not always easy, but that's how I would think about it, is try to figure out something that those non-residents do pay. Maybe a hotel tax or a rental tax or even raising fees on a bridge. You have to cross a non-resident fee for crossing over a bridge to get there, or something that those non-residents are going to have to pay and can't avoid. And once you've got that, then you can get it. But if you can't get it, then that's hard.
Okay, yeah, I think we'll knock it on the head there because it's 12:30. So thank you very much for the
Thank you.
I'll just go look at this if you want to hang out.
Okay. All right, great.
So then there's more questions that you can grab in there.